Okay, and this equation right here has actually the same base on the left and the right. It doesn't look like it, does it? Because it's got a 64 and a 4. But don't forget that 64 is actually a power of 4. The left-hand side could be written as 4 cubed to the 5 minus 2x, and the right-hand side can just stay as a 4x squared minus 12. The advantage to doing this is that now on the left we can write that as 4 to the 15 minus 6x because of the power rules for exponents, and 4x squared minus 12 on the right. And then we can perform a logarithm base 4 and just simply cancel out those 4's on the bottom and get left with only 15 minus 6x equals x squared minus 12. And hopefully that looks a lot simpler. So let's move over into the second stage of the problem, which is where we're going to solve this leftover. I'm going to put the x squared on the left, by the way. So I'm going to have x squared minus 12 equals 15 minus 6x. I'm going to add 6x, and I'm going to minus 15. So I'm getting everything over to the left-hand side. X squared plus 6x minus 27 equals to 0. That's a factoring quadratic problem. Let's see, can we think of two numbers that multiply to negative 27 and add to 6? Hopefully after thinking about it for a couple seconds, we could catch x plus 9 and x minus 3 as the numbers that work. And so therefore it looks like x can be either negative 9 or positive 3. So the answers are x equals negative 9 or positive 3. Okay, try this next one on your own. Pause the video. If you don't see the common base, you can watch me get the common base and then pause the video, but let's see if we can do this problem. So assuming you gave it a good shot here, tried it on your own a little bit. On the left we have 2 to the x squared minus 20x plus 71. Nothing going on over there. But on the right we have a 16, which is a 2 to the power of 4 to the 2 minus x. So again, big advantage, puts us at 2x squared minus 20x plus 71 equals 2 to the 4 times 2 is 8, and 4 times x is 4x. And then we can use a logarithm base 2 to cancel out those bases. So all that's left now is x squared minus 20x plus 71 equals 8 minus 4x. So now as I get ready to go over to the other side here, I'm also going to add 4x and add 4x to both sides, and I'm going to subtract 8 and hope we get something easy to work with. So we'd left with an x squared. Negative 20 plus 4 would be negative 16x. 71 minus 8 is 63, so I'm getting a plus 63 equals 0. So now I need two numbers that multiply to 63 and add to negative 16. Oh, that's convenient actually. That's x minus, wouldn't that be 9 and 7? X minus 9 and x minus 7. Yeah, 9 times 7, 63. 9 plus 7, 16. So that means the final answer to this problem would be either x equals 9 or possibly 7. X equals 9 or 7.